Okay, so for this is technically example number 4. Same thing. I'm going to have a triangle. It's really difficult to draw triangles on this thing. Well, it's really difficult to draw straight lines. Okay. I'm going to tell you that this is 3 and this is 7, and we don't know what this is. Okay. So maybe it's a ladder that's 7 feet long. It's 3 feet away from the house. How tall is the house? Maybe it's a flagpole that casts a shadow. Okay. What do I do? Well, I know that it's a right triangle. So I could probably use the Pythagorean theorem, a squared plus b squared equals c squared, right? Now, the only thing I need to identify on the triangle is which one, A, B, or C. Well, at some point, yes, but which one is the most important that I get right, that I can't make a mistake on? C, or the hypotenuse. So probably you guys were thinking hypotenuse, but C is always the hypotenuse. And where is the hypotenuse always located? It's across from the 90-degree angle. I know my 90-degree angle doesn't look like a 90-degree angle. I'll try to draw it a little better. Boy, I really butchered that. Okay, so across from the 90-degree angle is C. I could call this A, and I could call this B. Mathematically, it doesn't matter. I can call this A, I could call this B. It doesn't matter. C is important. I have to get the hypotenuse. I have to call it C. So then I'm going to say A squared is actually X squared. B squared is actually 3 squared. And then C squared is actually 7 squared, right? So we'll crank through this. What's 3 squared? Oops. 9, right? And if you don't remember, just a real quick reminder, 3 squared is the same as 3 times 3, which is equal to 9. 7 squared is actually the same as 7 times 7, which is actually equal to 49. Really need to calibrate this tablet. Okay. I'm going to subtract 9 from both sides. And then I have x squared is equal to 40. Now, here's something that's going to be a little different here. The textbook is saying you need to leave it as the exact value. So now what does that mean? Well, to get x by itself, I have to take the square root, right? Because I have x squared. What's the inverse of squaring something? Taking the root, right? So then the square root of x squared is actually x. Oh, but this is tricky. I need to simplify this radical, the square root of 40. So I need to think in my head, what is 40 divisible by with regards to a perfect square? So if you don't remember what the perfect squares are, the perfect squares are just numbers that are squared. So 2 squared is equal to 4. 3 squared is equal to 3 times 3, which is 9. What's 4 squared? 16, right? 4 times 4, that's where that comes from, equals 16. And you just keep going, but I need to think what one of these numbers divides into 40 evenly. 4 does, right? So one of the properties of square roots is that I can rewrite this as the square root of 4. How many times does 4 go into 40? 10 times, right? So remember that 4 times 10 equals 40. So this is a property of square roots that I can do. But what's the square root of 4? 2. So this is our final answer, 2 times the square root of 10.